This video is about review for writing polynomial functions for given zeros. For number 1, we are given irrational roots and also complex roots. According to this conjugate root theorem, which means for irrational roots and complex roots always appear in conjugate pairs. Therefore, 3 plus square root of 2 also the root, and also 6 plus I also the root. We will write down factoring form for each root. We got the x minus 3 plus square root of 2. Remember, x minus c is a factor form. So get the opposite for each term. You will get the x minus 3 minus the square root of 2. For complex roots, we got x minus 6 plus I. Then x minus 6 minus I. We got to do FOIL first. Like this 3, we got the x squared minus 3x minus square root of 2x. Then for this 3, we got to do negative 3x plus 9 plus 3 square root of 2. Then you will get this 3. That will be plus square root of 2x minus 3 square root of 2, then minus 2. Remember, any term with the irrational number will be cancelled out. Then combine like terms. You will get x squared. These 2, that's negative 6x. 9 minus 2, you will get plus 7. Now let's work on x minus 6 plus I times x minus 6 minus I. This 3, you will get the x squared minus 6x minus ix. Then we do this 3. You will get negative 6x plus 36 plus 6i. Then you need to do this 3 now. Plus ix minus 6i minus I squared. Remember, I squared equals 1. Therefore, for this one, that is plus 1. Then any term with I will be cancelled out. Then you combine like terms, x squared minus 12x plus 37. Therefore, I can write down f of x equals a times x squared minus 6x plus 7 times x squared minus 12x plus 37. According to the given information, when x approaches negative infinity, y approaches negative infinity. As we know, leading term determine the end behavior for this polynomial function. Leading term, that is a times x squared times x squared. You will get the ax to the 4th power. Any polynomial with the leading term ax to 4th power has the same end behavior as x squared or negative x squared. Either go this way or go this way. Since when x approaches negative infinity, y go to negative infinity will be this pattern. So a less than 0, we can choose a equals -1. Therefore, f of x equals -1 times x squared minus 6x plus 7, then times x squared minus 12x plus 37. Now let's go to number 2. We are given this 3 roots. According to conjugate root theorem, we have a positive I, also the root. Therefore, we can write down the factor for each root. That will be x plus 3, x minus 2. And also we have x minus I, x plus I. According to a plus b times a minus b equals a squared minus b squared, while a plus bi times a minus bi equals a squared plus b squared. Therefore, we got the answer x squared. 1 will be the b, so plus 1. Therefore, I can write down the polynomial function as a times x plus 3, x minus 2, and also x squared plus 1. For the given information, y-intercept, that's 12, so f of 0 equals 12. I'm looking for f of 0. I change every single x as 0, so we got 0 plus 3, 0 minus 2, and 0 squared plus 1. Work this out, you get the a times 3 times negative 2 times 1. So we got negative 6a. Since f of 0 equals 12, I put the 12 here. Then we divide by negative 6. A equals negative 2. Therefore, the polynomial we are looking for is negative 2 times x plus 3, x minus 2, x squared plus 1. This is the answer to this question.